everybody. We're going to continue on in Chapter 8 today. And so far, we've just introduced the similarity chapter and the ideas of how to find similar figures. Now we're going to go on and do a theorem, actually, where you can take two triangles and you can prove that they are similar, which is almost congruent, using the similarity theorem. And then we'll do some real life problems. So the only two vocabulary words you can see are that we know from before is similar figures and similarity transformation. So that's all we're going to do is introduce the theorem with a couple of examples and then do some real life problems. Here we go. So here's what the theorem says. If two angles of one triangle are congruent to two angles of another triangle, then the two triangles are similar. So you can see that A is congruent to D, B is congruent to E, therefore triangle ABC is similar to triangle DEF. And you'll notice that that squiggly, the tilde, shows you the similarity sign. There is a proof here using scale factor. It is a paragraph proof, okay, where you basically dilate this one and then you prove by some of the other triangle congruences, angle side angle specifically, and then you map that composition of rigid motions so you get that ABC, A prime, B prime maps to EDF. And that is the case. Again, it's also in your book, so I'm going to let you see that if you want. Here's an example where we're going to use this theorem.
Determine whether the triangles are similar. If they are, write a similarity statement. Explain your reasoning. Solution. The angle-angle similarity theorem states if two angles of one triangle are congruent to two angles of another triangle, then the two triangles are similar. So try to show two pair of corresponding angles congruent. Because they are both right angles, angle D and angle G are congruent. By the triangle sum theorem, the measure of angle C plus the measure of angle D plus the measure of angle E is equal to 180 degrees, which means 26 degrees plus 90 degrees plus the measure of angle E is equal to 180 degrees. So use the subtraction property of equality, and the measure of angle E is equal to 64 degrees. So angle E and angle H are congruent. So triangle CDE is similar to triangle KGH by the angle-angle similarity theorem. You can use colored pencils to show congruent angles. This will help you write similarity statements.
They say colored pencils, I like highlighters, whatever works for you. Okay, here's a second example. Follow along.
Show that the two triangles are similar. Part A, triangle ABE similar to triangle ACD. Part B, triangle SVR similar to triangle UVT. Solution. Part A. You may find it helpful to redraw the triangles separately, as shown. Because the measure of angle ABE and the measure of angle C both equal 52 degrees, angle ABE is congruent to angle C. By the reflexive property of congruence, angle A is congruent to angle A. You have shown two angles of one triangle are congruent to two angles of another triangle. So, triangle ABE is similar to triangle ACD by the angle-angle similarity theorem. Part B. You know that angle SVR is congruent to angle UVT by the vertical angles congruence theorem. The diagram shows with the red arrows that segment RS is parallel to segment UT. So angle S is congruent to angle U by the alternate interior angles theorem. You have shown two angles of one triangle are congruent to two angles of another triangle. So triangle SVR is similar to triangle UVT by the angle-angle similarity theorem.
So you can do two different types of examples there. Hopefully you'll be able to use the theorem easily. Now we're going to go on. These are problems in class. And previously you learned a way to use congruent triangles to find measurements indirectly. This would have been in Math 8 when we did all those transformations. Another useful way to find measurements indirectly is by using similar triangles. So again, hopefully this looks familiar from previous math classes. And here we go.
A flagpole casts a shadow that is 50 feet long. At the same time, a woman standing nearby who is 5 feet 4 inches tall casts a shadow that is 40 inches long. How tall is the flagpole to the nearest foot? Solution. Step 1. Understand the problem. You are given the length of a flagpole shadow, the height of a woman, and the length of the woman's shadow. You need to find the height of the flagpole. Step 2. Make a plan. Use similar triangles to write a proportion and solve for the height of the flagpole. Step 3. Solve the problem. The flagpole and the woman form sides of two right triangles with the ground. The height of the larger triangle represents the height of the flagpole, and the base of the larger triangle represents the shadow of the flagpole. You are looking for the height of the flagpole, so let x feet represent the height of the flagpole. The flagpole casts a shadow that is 50 feet long, so label the base of the larger triangle 50 feet. The height of the smaller triangle represents the height of the woman, and the base of the smaller triangle represents the shadow cast by the woman. The woman is 5 feet 4 inches tall, so label the height of the smaller triangle 5 feet 4 inches. She casts a shadow that is 40 inches long, so label the base of the smaller triangle 40 inches. The sun's rays hit the flagpole and the woman at the same angle. You have two pairs of congruent angles, so the triangles are similar by the angle-angle similarity theorem. This means you can use a proportion to find the height x. Write 5 feet 4 inches as 64 inches so that you can form two ratios of feet to inches. Write a proportion of side lengths. X feet divided by 64 inches is equal to 50 feet divided by 40 inches. Use the cross products property, and this gives you 40x is equal to 3,200. Solve for x by dividing each side of the equation by 40, and x is equal to 80. This means the flagpole is 80 feet tall. Step 4. Look back. Attend to precision by checking that your answer has the correct units. The problem asks for the height of the flagpole to the nearest foot. Because your answer is 80 feet, the units match. Also, check that your answer is reasonable in the context of the problem. A height of 80 feet makes sense for a flagpole. You can estimate that an 8-story building would be about 8 times 10 feet, which equals 80 feet. So it is reasonable that a flagpole could be that tall.
You always want to check your answer for reasonableness, because if you get some crazy answer that doesn't make sense, you probably need to check it. Okay, here's another one that we'll do in class together. And here it is for exercises. So I'm just going to keep this video nice and short. The notes will also be nice and short, and we can get right to work.